I welcome you back to my YouTube channel of Smart Science. I'm going to be with A-level students still, continuing on Group 2 Chemistry from where we stopped in our recent video. Today, we are going to look at chemical properties of Group 2 elements. And in this case, we are going to begin with number 1, where we look at the reaction with water. Before we discuss how group 2 elements react with water, I would like to remind you that in group 2, we are looking at elements like beryllium, magnesium. From magnesium, we go to calcium. We look at strontium, and we also look at barium. And when we are looking at these group 2 elements, their reactivity with water is determined by electropositivity. And we are going to realize that reactivity with water increases down the group. And this one is due to increase in atomic radius as you move down the group, which reduces effective nuclear charge. And because of this, outermost electrons become loosely attracted towards the nucleus. And because of that, there is increase in electropositivity of the metals. And because there is increase in electropositivity, definitely reaction with water will increase as we move down the group. So when we consider the first element, beryllium, this one doesn't react with water. It doesn't react with water at any given condition. So we can realize that as we move down the group, the activity increases. When you're still at the topmost part of the group, the activity of the elements is very, very minimal. When it comes to magnesium, an element known as magnesium, this one reacts slowly with cold water, forming magnesium hydroxide, and hydrogen, which is a gas. And normally, we defend our answers in inorganic chemistry by show of equations. So if I have magnesium reacting with water, we are going to form magnesium hydroxide, which is aqueous, plus hydrogen, which is a gas. We shall be requested to balance for oxygen, and likewise hydrogen will end up balancing at 4. As we move on to look at the different reactions with water, definitely you're going to look at another scenario where heated magnesium, in all your statements, conditions are very paramount. This one reacts vigorously or readily with water in form of steam to form magnesium oxide, and definitely liberates hydrogen, which is a gas. And whichever statement you write, make sure that statement is defended by an equation. In this case, our water is in form of gas. We shall form magnesium oxide and hydrogen, which is a gas. The equation is balancing, so there is no need of looking at any way of balancing it. If we look at the last category, which has calcium, strontium, and barium, these ones, calcium, strontium, and barium, these ones react vigorously with cold water to form their respective hydroxides, and definitely to also form hydrogen, which is a gas. Now, since these three share the same property, we can represent them with a general equation where X is solid. We are reacting it with water, which is a liquid, and we shall form X hydroxide, which is aqueous, plus hydrogen, which is a gas. We shall end up balancing to ensure that all the atoms at either sides of the equation are balancing. However, the moment you use a general equation, you have to tell us the elements which are represented by the unknown you've used. So where X represents calcium, it represents strontium, and it also represents barium. So the activity of these elements with water will depend on electropositivity, the ease to release the outermost electrons so that they can behave as reducing agents. Definitely, that is property number 1. If we cross to property number 2, we are going to realize that under property number 2, we shall look at reaction with the oxygen, reaction with oxygen, and we shall realize that all the heated metals, all the heated metals react with oxygen and form respective oxides. And since this property combines all, I can use an unknown to write a general equation. In this case, the oxide formed is a solid, and we shall balance it where simply our x represents beryllium, magnesium, calcium, strontium, and barium. Now, when you're looking at these oxides, it has not been requested for. However, we need to be knowing it, that the oxide of beryllium is going to be amphoteric, as all the others give us basically oxides. So under the properties of the compounds of group 2, we should ensure that the oxides, we should look at the nature of the oxides formed by each of the elements suggested. As we move on, in excess oxygen gas, heated barium reacts to form barium peroxide, i.e., if I have barium and I react it with oxygen, which is a gas, I'll form barium peroxide, which is a solid. And the equation will balance itself. So the conditions, like I've insisted, are always paramount. This barium should be heated, and we are suggesting that the oxygen should also be in excess. When you look at this side, all the metals must be heated. And lastly, after the conditions, we would prefer looking at the names of the products formed. So in each and every statement you mention, make sure that you have suggested the different products that are to be formed. 3, we can look at reaction with nitrogen. Reaction with nitrogen. And when we look at reaction with nitrogen, we shall pick out only 2 elements, calcium and magnesium. When heated, these ones when heated react with nitrogen to form respective nitrides that hydrolyze in water, and water to liberate ammonia gas. They hydrolyze in water to liberate ammonia gas. So when we represent this with an equation, you can decide to use a general equation where I react it with nitrogen. The product formed is X3 because the valence of nitrogen is 3, and the N2, which is a solid. So I'll come on and balance, and I'll say where my X represents. My X represents calcium, also magnesium. So as a student, you can come on and write individual equations, which will involve 3 calcium, which is a solid, plus nitrogen, which is a gas. These ones should give you calcium nitrate, which is a solid. If not, we shall consider 3 magnesium plus nitrogen, which is a gas. These ones should give us magnesium nitrate, which is solid. So that's how we are going to look at the reaction with nitrogen. 4, we can look at reaction with the alkalis. And this one is especially sodium hydroxide. And when we consider this property, it is beryllium which has ability to react. So beryllium reacts with hot and concentrated sodium hydroxide to form a complex and hydrogen gas. As we're writing the formula of this complex, I shall be in position to name it. So if I have beryllium, which is a solid, I react it with hydroxyl ions from sodium hydroxide in presence of little water, and this one will take me to a complex which is of 2- aqueous plus hydrogen gas. And we will balance. In balancing ionic equations, we consider normally 3 particular rules. Number 1, we balance charges, we balance oxygen, and we also balance hydrogen. These are the 3 main areas which we balance. In order to balance for oxygen, make sure that you add water. It is the reason as to why we've introduced that water. For you to balance for hydrogen, we simply add hydrogen ions. It is not the case here because hydrogen can balance, and this one add electrons, which is also not the case in this equation. So we have only used rule number 2, which wanted us to balance for oxygen, and lastly, we are going to balance the charges. I have -2 here. So in order to balance these charges, I will go to this side where there is a negative. I also multiply it by 2. These are 2 plus 2 hydrogens, which makes it 4. but here we have 6. So for me to increase, I need 4 oxygens. Already I have 2 here, so I should multiply water by 2 to ensure that the equation can also balance. So as we write this complex, we leave when we have named it, because for any complex written, begin with the number of the ligands attached, and the number is 4. In science, 4 means tetra. We have OH attached, and that ligand is known as the hydroxyl. And then we have beryllium. It changes the name to berylate, simply because the complex is negatively charged. So this one is a tetrahydroxyl berylate 2 ion complex. So that is how beryllium behaves with alkalis. All other elements of group 2 don't react with the alkalis because they are basic. So it is only beryllium, which we've looked at here, which has a unique property, and this is amphoteric. Because it is amphoteric, it can react with both acids and alkalis. That's why we are seeing it reacting with sodium hydroxide. As we move on, we look at reaction with acids. And for this one, I have an acid known as dilute HCl, or dilute hydrochloric acid. Simply dilute HCl. This one liberates hydrogen gas when reacted with the metals at temperature. So if I have a metal and I react it with the acid HCl, we all understand that an acid releases a proton in solution. We shall form a salt of that metal, and then we shall also liberate hydrogen gas. And the acid number 2 is sulfuric acid. Likewise, dilute sulfuric acid reacts with the metals to form their respective sulfates and hydrogen gas. However, the reaction stops for calcium, strontium, and barium, simply due to formation of insoluble sulfates that prevent further reaction, i.e., if I have X reacting with sulfuric acid, which is aqueous, I'll form X sulfate, which is aqueous, plus hydrogen, which is a gas. And in this case, where X is equal to beryllium and then magnesium, that's where we shall form a soluble sulfate. However, if I have calcium, it reacts with sulfuric acid. To react with sulfuric acid, which is aqueous, simply to form calcium sulfate, which is a solid, plus hydrogen, plus, because this is a solid, it prevents further reaction, and it is the same case which will occur if you use strontium or when you use barium. Definitely here, we shall be getting strontium sulfate, which is a solid, or barium sulfate, which is also a solid. With concentrated sulfuric acid, it has to be hot, so hot and concentrated sulfuric acid, this one reacts with metals like beryllium and definitely magnesium to form respective sulfates, sulfur dioxide, and water. So i.e., if I have beryllium, I react it with sulfuric acid. This one can be represented with a liquid. We shall form beryllium sulfate, aqueous. We shall form sulfur dioxide. We shall equally form water. And balance, I realize that we are multiplying sulfuric acid by 2. Definitely water will also be multiplied by 2. And as we move on, concentrated nitric acid, this one normally renders the metals passive. So they tend not to react with concentrated nitric acid. Thank you for following today's discussion. We shall still continue with more highlights of group 2 elements and how they react. Keep on subscribing, and if you have any level learner who is doing chemistry, please share the link. Let such people subscribe, like, and comment where necessary. Thank you very much. I remain Smart Science. Thank you for listening.